sometimes it's not going to be labeled. Sometimes on your test it's not going to be labeled. And that's why you need to be able to look around at the information that's given to you and see, what can I do? What can I figure out? So Ayana says that I know that this is 1 centimeter. And what type of shape is this? It's a square. So what does that mean, Beck? Each side is what?
1 centimeter.
So each side is 1 centimeter. So when you guys copied this onto your paper, you could have copied it further, and you could have put this if it made it easier for you to look at. Okay? That's what it said before, but that's just labeled even more for you. So the first question is, what is the perimeter of this polygon? Some people got wild answers. I mean, like, it was huge. It was like you guys are walking around in Central Park or something. It was crazy. So how do we find the perimeter? Or what is the perimeter? What's the perimeter?
6 centimeters.
But how do you find the perimeter? So you say the perimeter is 6 centimeters. I'll put that answer right here. But I want you to tell me how you found it.
I counted all the boxes.
So you counted all the boxes? Like this? 1, 2, 3, 4, 5, 6? Okay, so that's how you found the perimeter. Did anybody find the perimeter a different way?
I counted all. It just measured all the sides.
So you measured all the sides. So is this the side or is this the side?
This is the side.
Okay, so you have one side, but how many sections does the side have?
3.
Okay, so you have 3. So how could I label this? So I could label this as 3 centimeters. You see anything different? That's 3 centimeters. Why? Because this is 1 centimeter, this is 1 centimeter, and this is 1 centimeter. So you could label them separately if you want and just put 1 next to each of them. But I want you guys to look at the pieces on your desk. You have all your little squares and you made this shape. I want you, because you always tell me that the perimeter is the distance you what? Walk around the outside. So make your little walking fingers. Walk around the outside. Now pay attention, when you walk around the outside, touch every edge. And every time you get to a new color or a new little square, count. So when you walk around the edge, what are you getting? Christian, what are you getting?
I keep on missing one.
Alright, so start with your piece right here. Start here. Ready? 1. And then what?
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
12? But you told me it was 6. What do we think?
I messed up.
Maybe. Does anybody else have an idea what they think? Anybody over here? What do you think? Look at your pieces. What do you think? 12? Why? Because you went all the way around it. So Paul, I want you to trace around it with your finger. And I want you to count. So it's not that, bless you, it's not that every block just has 1 centimeter. Every block's perimeter is actually what? Every little block's piece is actually 4, okay? Centimeters. This is actually an inch, but we're going to pretend it's a centimeter. Okay, so 1, 2, 3, 4. Not just 1. What would 1 be? What's 1? 1. What would the 1 be for, actually, Sebastian? A line. What would the 1 be for? 1 whole. Okay. Janessa, do you have something more to add to that? 1 whole. Okay. So each block actually has a 4 centimeter perimeter. But do you count the perimeter of each side? Do you count the perimeter of each side? No. Why not? Why not? Because what's the perimeter?
4.
Is what?
The outside
The outside of
the shape of 4.
the shape. Are we going to touch this when we're walking along the outside?
No.
It's like a fenced-in area. Think about that as like a playground. Think about that as different things that you could picture. It's like your pool. You don't go walking inside your pool. Are you going to walk inside your pool?
No.
Can you walk on water?
No.
Can you? No. I can't walk on water either. So I can't walk on my pool. I have to walk around the outside. Since you guys always say that perimeter is walking around the outside, these are blocks that are the same. And I can make that shape out of them. When I put them here, Sebastian, come here. When I put them here and I make this shape, and I make it like this because you guys always say it's when you're walking around the outside of it. Walk around the outside of this. Actually, walk around it. Go ahead. And tell me, count. How many? Touch each one. The outside of it. Ready? 1. Yeah. Yeah. Now turn your corner. Turn your corner. 4. Yeah. Ooh, don't miss a corner. You missed.
7, 8,
Yeah.
9, 10, 11, 12.
Do you see that? 12? Does that make more sense to you? Because you had a really big mark. It's okay. It's totally fine. But do you see now why 12? Okay? Does everybody else see that, or does somebody else need to walk around it to actually see that? If you want to, it's fine. Do you understand, Paul? You do? Okay. So now, also, thank you. So now, the perimeter is what, my dear friend? You answered first. What do you think the perimeter is now?
12.
Are you pretty sure about that? Why? Because we actually physically walked around it like we said. And it's 12 because we have 1, 2, 3, and then how many here? 3 again. We have 1, 2, 3. 3 centimeters. And then here, what is it? 1. Kaylee, what's here?
1.
And put the water bottle somewhere else. Okay? And here. Here. 1. Here, Giannis.
1.
What about, should we skip this? Well, we already counted it over here. Why count it again?
Because we're walking around the whole block.
Okay, because we're walking around the whole shape. All right, so what about this? Michelle, what should I do?
1.
Done?
No.
Then what?
The top.
The top. So Becca, count all the ones with me. Ready?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
12 what?
Centimeters.
12 centimeters is our what? Our perimeter. Very good. So now does anybody have any questions on that? Okay. All right, so what's our question 2?
Miss H,
Yes?
teacher sweared and I need to use the bathroom.
You just went to the bathroom. Why don't you do this with us and then we can think about it, okay? You participate on this one and then we'll talk about it. So, Lily, if you would like to participate, you could probably tell us the formula for area. What's the formula for area?
Formula for area is,
I don't know. Isaiah? Length times width. So, A equals length times width. Now, for this problem, is there an easier way than figuring it out? So length times width. 3 times 3. Can I do it that way? 9. 9 centimeters squared? No, because I would need the whole full shape for that. It's not a perfect square or rectangle, is it? So I can't do that. So I could break it up and I could do each box of length times width separately. Or what else could I do? This is why this was a simple problem but a tricky problem. It's true. Somebody else. Now there's a lot of ideas. So somebody else. So what else? Other ideas? Evans, what could you have done? Instead of multiplying length times width, what could you figure out? Even look at the little blocks on your desk. Look at these. Look at these. I just destroyed her shape. But I'm sure she can make it again, right? So, when you look at this, look at these. Look at your shape. It's going to be hard to find the area if you're going to multiply the length times width because you have to break it up what? So somebody on their paper actually did something that I thought was really, I don't think inventive is the right word. I don't know who did it either. I can't remember. It might have been a nameless person. But you did this, and you did 6 times 1 equals 6. And then you did 1 times 1 equals 1. And then you did 6 times 1 again equals 6. Who did that? Who did that? You did that. Okay. I thought that was really good. That is definitely a different way of thinking about it. And you know what? I think that is a great way of thinking about it. But can you explain it to us? What did you mean by 6 times 1 and 1 times 1? Where did that come from?
The one came from the sides of the box.
The 1 came from the sides of the box. Okay.
And then the 6 came from when I counted the boxes.
And then the 6 came from how many numbers of boxes there are. So she multiplied, first, the number of boxes by their side length, which is 6. And then she multiplied 1 times 1 because that's the length and the width of each box. And then she multiplied 6 times 1 again because that's the number of boxes and that's the area for each box. That's pretty impressive. That's good. That's good. I'm very proud of you. I was quite amazed. So when she looked at the area of each box, is there another way you looked at it? Because I'm going to be honest with you. I love this way, and I think it shows a lot more thinking and higher thinking than the other way that I just thought of. It's true. So you're above me on that. So who did it a different way? Who did it a different way? Giannis, how did you do it? How else can you do it? How else can you do it? Haley, what are you thinking about? This is your boxes. These are all split up into separate boxes. How can you find the area? Yes. Okay, so what did you do? You cut your shape into 3 different parts like this, and then the bottom 3? Okay. So you cut your shape into 3 different parts and then what did you do? Okay. Okay, so what did you do here? Okay. Okay, and then you, what? And then she added all of the things that equaled each other, or were this quotient of her things together, and you got what? 1 plus 2 plus 3 equals what? 6 what? Centimeters squared. Okay, so that's another really great way to do it. In a different way. That's really good. I didn't think of that way. So that's similar to Renee's, but you broke it up. That's great. I'll be honest with you, I didn't think of that way. That's good. That's very good. What's another way? It's like the simplest way. Alright. Sebastian, again. She's gonna bathroom. Oh, yes. Okay. This is the shape. We can pick up this shape just like you can pick up all your shapes. Pick it up and I want you to tell me each one of these blocks according to the key is 1 centimeter squared. Pick it up. 1 centimeter squared.
1 centimeter squared. 2 centimeter squared. 3 centimeter squared. 4 centimeter squared. 5 centimeter squared. 6 centimeter squared.
What's the area?
6 centimeter squared.
The area is 6 centimeters squared. Pick up your shapes one by one and count. That's how simple the area is for this problem. I know it seems like, thank you, it might just be too simple, but that's why. Don't trick yourself and make it more difficult. What did you get? What did you get? You.
6 centimeters squared.
Paul, pick up your pieces one by one. 1 centimeter squared. Count.
1 centimeter squared, 2 centimeters squared, 3 centimeters squared, 4 centimeters squared, 5 centimeters squared, 6 centimeters squared.
What'd you get?
6.
6 what? 6
Oh.
chickens in a row.
Centimeters.
Centimeters? That's it? 6
Square.
centimeters? 6 centimeters squared. So everybody had the same problem. So everybody should have gotten that answer. And like you guys see, there's so many different ways to do it. Do which way you feel most comfortable with. We've showed you different ways, and now you're exploring different ways on your own. And that's awesome. So find something that you find comfortable. Some people simply just did this. 1 centimeter squared. And they counted down like that. That's all it is. Sometimes in other problems, it might be more than that. But focus on what the problem is asking you. Don't make something into what it's not. Okay? So that's all you have to do. Or you could, so these are once I added them. I went from 1 to 2 and 2 to 3 and 3 to 4 and 4 to 5 and 5 to 6. I could have just put 1 centimeter squared, 1 centimeter squared, 1 centimeter squared, and added them all up. Okay? Sincere. Okay. Alright, does anybody have any questions on that? Any questions at all? Do you understand that? Does it make it a little easier when you have something, some type of manipulative? Yeah, it makes it easier to see. So make those for yourself in your head. Draw those out on your paper. Explore them and look at them when you are asked to do something. Okay? Any questions? Last call for questions. Okay. Alright, Sebastian, why don't you go